Welcome to this LTspice video tutorial. In the last video, I showed you how to take this RC filter schematic and run a transient simulation on it. In this video, I'm going to show you how to run an AC simulation on this same schematic. So the two things we will need to run an AC simulation is we're going to need an AC input source, and we're going to need an AC simulation directive. So to add the AC input source, we're going to click on this voltage again. That is where we set up our pulse. So we're actually going to leave the pulse alone. We're going to leave it there and let it continue to do, to sort of run that function. But we're also going to add an AC amplitude. I'm just going to put a 1 here. So any sort of AC simulation that you run, it's going to use this as sort of the input signal value. So when you set it to 1, that just references anything that you're measuring to the fact that your input was 1. You could make this any value you want, but I think for most cases 1 is the most sensible choice here. So I'm not going to worry about putting a phase, and then I am going to make this information visible on the schematic. And so let me zoom out. And now you'll see that the voltage source has both the pulse information and the AC information. So the pulse information will not be used unless you're running a transient, and the AC information won't be used unless you're running an AC simulation. So the other thing we'll do is we need to add an AC simulation directive. I'm going to right click on this transient directive. I'm actually going to leave it alone. So I'm just going to leave the transient information as it is, but I'm going to add an AC analysis. So I usually will do a decade type of a sweep. You see you have all these different options, and basically the difference between an octave, a decade, and a linear is how many points per, that distance. So when I pick decade, and then I'm going to say number of points per decade, it would be the same. If you were doing linear, then it would be, number of points per division, which would then be more linear divisions instead of like a logarithmic division. So I always do this because for a lot of circuits like this, the response has sort of a logarithmic feature to it. So it's easier to look at this way. I'm going to, this is somewhat arbitrary. It just depends on when the activity of your circuit is going to be happening. So I could just do 1 hertz here. Depending on my simulation, if I see that that's not, if it doesn't make sense, I can always change this later. I will make it stop at 1 meg. So I talked about this in a previous video, but I will, bring this up again. In LTspice, there is a difference between, so if I had done 1M like this, LTspice would actually interpret this as a milli. So it would see 1 millihertz is where it would stop. And honestly, it would probably yell at you because your stop frequency is actually less than your start. So anytime that you want to do meg, you're going to want to make sure that you type out the full meg. If you're ever concerned or worried, you could always just do like 1000 K, and then for sure. But you're also safe to do meg if you can remember. And so if your simulation's ever doing anything, really odd, that would be one thing to maybe try to remember to check is, did you use milli where you meant to, and did you use meg where you meant to? So I'm gonna say okay. And so now I'm gonna move this so that it's not in the way. So now I've got my 2 simulation directives. The transient one, it's shown in blue, which means it's commented out. And then it's the AC directive that's the one that's going to be active when I hit run. So at this point, I will hit run. And I've got no errors, so I'm going to assume that everything worked fine. So again, similar with the transient, you would just click on the node to plot it. So plotting the N isn't going to be very interesting because I just set that to be 1. So it's just going to be 1 all the way across. So I'm actually going to even delete that because it just isn't very interesting. I'm going to plot the out. And so that's where you can see, something that's more interesting and what you would expect. So we've got, our starting at the 0 dB, because we had set the input to be 1, which would be equivalent to 0 dB. And then you can see that it starts to roll off. Similarly with the transient simulation, you can also plot current. So if I want to see what the current is through this capacitor, and then if I also want to make things a little bit easier to look at, I can add a plot pane and bring this down. And so now I can look at both current and voltage. So something else, we talked about measuring using the zoom feature, but you can also measure using the cursor. So the way you would bring up the cursor is you would just click on the signal that you want to measure, and that's going to bring up this crosshair, and it also brings up this measurement window here. So I can drag, so you can see here I've got my cursor 1, and I can drag it across. I can use my up and down arrow to change which signal I'm probing, although the only way I can do that is if I have them on the same window, I guess. So I can go up and down to change which value I'm probing. And then I can also click on the signal again to get a second cursor. And so with the second cursor, you can now measure distances. So let's say I want to measure from, I don't know, let's see. Let's say I want to measure how far it is from, or what my drop is from, let's say 1 kilohertz to 10 kilohertz, which this should be like a 20 dB difference. And so if we look over here, we can see the ratio. So, and I didn't quite get my cursors in the right place because it's showing I'm 9 kilohertz apart, which I was hoping to be 10. So there we go. Say somewhat kind of fumbling here. But anyway, so this will give you information about where your cursor 1 is, your cursor 2, and then here it's using the ratio of cursor 1 and cursor 2. Let's see what happens if I change. So I'm over here in a dB scale. If I change it from dB to logarithmic, you can see a different set of numbers if you're more comfortable thinking about things in terms of their linear numbers. And then also you could even change it to linear and look at things differently that way as well. Let's look at this, get this back down here. So just some different ways that you can make measurements. Let's remove this altogether and go back to logarithmic. And then let's just measure with one cursor. And so, for example, we can look at, maybe try to measure the 3 dB point. So if we change it to dB, and we try to find, and I could even zoom and try to find the 3 close enough. And so 159 hertz. So that's just to show you some of the things you can do with cursors. Last thing I'll show you, since we're in an AC simulation, is you can see, let me zoom out. You can see that it's showing, it's plotting two things. It's plotting the magnitude of your signal, but it's also plotting the phase with this dotted line. So you do have some control over that. You can turn off the phase plot if you want. So it's just something to be aware of. Turn it back on. So that is it for AC simulation.